In this video, we'll be talking about the full subtractor circuit. Before you go through this video, make sure that you go through my previous video on half subtractor. Let's move on to this video.
Full subtractor. We are going to have 4 items in this video. The first one is, what are we going to do in this video? And second one, what are the limitations of half subtractor? Why do we require full subtractor? And what are the theory behind it? And third one, we are going to design the full subtractor with the help of truth table, and from that truth table we are going to get the Boolean expressions, and with the help of Boolean expression, how are we going to design the logic diagram? Then finally, we'll be implementing the design using logic gate simulator. So, aim is to design and implement full subtractor using logic gate simulator, and here you are going to have 2 tasks. One is with the help of the discrete gates, NOT, XOR and OR gates, you are going to implement the full subtractor. And second task, it's going to be your practice task, where you will be using 2 half subtractors and 1 OR gate to implement the full subtractor. Before we begin the theory, let's see what is the limitation of half adder. Why do we require this full subtractor? Half subtractor is used for the purpose of subtracting 2 single bits. But the main drawback is, we are not going to take into account the borrow in from the previous bits or previous operation. This is the major drawback of half subtractor, since in real time scenarios where you require the operations with multiple number of bits which cannot be accomplished using half subtractor. So only way is full subtractor comes into play. So if you see the full subtractor, it is a combinational logic circuit where your output at any instant of time depends on all combinations of your input, it doesn't have the memory. It is used for the purpose of subtracting 2 single bit number. It contains 3 binary inputs and 2 binary outputs. It has the ability of subtracting 3 bit numbers. Okay. So basically it also takes into consideration borrow of the lower significant stage. So here is your full subtractor block where you have inputs 3 and outputs 2, and if we label A is one of the inputs, B and B in. So here the label is B in represents borrow input, and D is the difference, and B out would be your borrow. Let's go to the design. Step 1, identify the input and output variables as we have done already. A, B, B in are my input variables. Those can be either 0 or 1, and your output variables are D difference, B out, borrow. Step 2, draw the truth table, and A, B, B in are my inputs, D and B out are my output. If I have 0, 0, 0, I have the difference 0 and B out 0. If I have the same input B, A and B, both are 0, but if I have a borrow in, then my difference would be 1 and my borrow output would be 1. Then if I have 0, 1, 0, I have the difference 1, my borrow out 1. Then I have 0, 1, 1, my difference would be 0 and my borrow out would be 1. and if I have 1 0 0, my difference would be 1 and borrow would be 0. Then if I have 1 0 1, my difference would be 0, my borrowed would be 0. If I have 1 1 0, my difference would be 0, my borrowed would be 0. If I have all ones, my difference would be 1, my borrowed would be 1. So basically here the difference you will get A minus B in, right? So if we closely observe the column D is equal to 1 when only one input is equal to 1. If you see here I have only one input 1, where I get D as 1, or when all three inputs are 1. From the obtained truth table, we are going to draw the Cape map and determine the simplified Boolean expression. So let us form the map. So for difference, I'll be having the map 3 inputs A, B in, then 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay, so I will just look into the column D, where I'll be having all 0, I'll put 0, then 0, 0, 1, I have 1, then 0, 1, 1, I have 0, then 0, 1, 0, I have 1. Okay, then 1, 0, 0, I have 1, then 1, 0, 1, I have 0, then 1, 1, 1, I have 1, then 1, 1, 0, I have 0, right? So as we said, D is 1 when only one input is present or all the three are present. Okay, so this is for difference, and if you write the expression for the difference, you could see it is very similar to your full subtractor, right? So D is equal to A XOR with B XOR with Bn. Next for the borrow B out. So I will look into the B out column and I will fill the table. So if you do this, then at the end of the day I will be arriving to two Boolean expression. Like one is using sum of product, you get one, then after simplification you will be having the another one, which can be written as, the first expression is B out is equal to A bar B in plus A bar B plus B in, and next one you get is B out is equal to A bar B plus A XOR B whole bar into B in. So for difference you have only one expression, but in borrow or full subtractor you have two expressions, either of one we can use. And here I am going to now draw the logic diagram and implement this diagram in the logic gate simulator, and the practice task would be with the second Boolean expression what you are going to perform as a practice exercise. Okay, let's see the logic diagram where I have the difference D is equal to A XOR with B XOR with B in, right? If I want to obtain this, I would require two XOR gate, right? First XOR gate I will pass AB, where I will get the output as A XOR B, and that will be given as input to the second XOR, and I will take one of the inputs B in. So finally I will get the difference A XOR with B XOR with B in. So I am done with the difference. The next one I am going to have three AND gate, where I perform the multiplications and I need the inverter, right? A bar is there. So I will require the inverter, NOT gate, right? So I will just take first what is this gate output. One is I am just taking B, another input I am taking A bar, that is the first one, that is this one, right? A bar B. So this will provide you A bar B, and this one A bar B in, right? So this is A bar and this is I am taking B in. So this will give A bar B in. Next one, what is that I am having? B in. So I am just taking B, then B in, right? Here I get B in. So A bar B in, B in. So I will ultimately add all. So first I will just take the addition of this, then I will just take the output and in OR with the output from the AND gate of this, right? So finally I will get B out is equal to A bar B in plus A bar B plus B in. Okay. So now we are going to try in implementing this logic diagram in the logic gate simulator. Let's see. So I have opened this logic gate simulator. So first let us perform for the division, okay, sorry, difference. So that is I require XOR gate, 2 XOR gate, right? So I will just do Control C, Control V. So I will take the input, Control C, Control V. So let me take another for B in. Okay. So then I will require the output. Then I will just take Control C, Control V. Okay. So I will be having let me call this as A, this as B, and let me call this as the another thing, let me call this as E. Okay. First I will just do the connection. So A, B, right, to the XOR first, then I will connect this and I will take this. Okay, so what is this? What is this? This is nothing but your difference D, right? So what is the expression here? What do you get? A XOR B XOR with E, right? So E here will just take it as B in. Okay, so we are done with the difference. Okay, next one is what? We are going to see the B out. Okay, so for that I need to have the NOT gate, right? So I need to invert the A. Then I would require 3 AND gate, right? So I will probably do copy and paste and one more, right? So I will have, so what is the first expression? A bar B. So I will just take this A bar B, right? Okay, so I will just take it here. So A bar B, then I need A bar B in. So here B in is E. Okay. Then I need B in, right? B in. So I will just take B here, then B in. Here I have E. Okay. So finally what I have to do? I need to add all three, right? So that is my B out. So what is this expression? A bar B, A bar B in, B in. So I need to add all three. So I require the OR gate, right? So here in the presentation you would have seen I have used two OR gate to add the two bits. So here if I want to add the multiple input, you can always do right click, add input, right? You can do the addition of 3 bits also, right? So here single bit OR operation you can do in adding multiple inputs. So I will just take this as one of the input, and this is the next, and this is my next, right? So this would be your B out. So I just label this as O. Okay. So shall we verify? So now that this is going to be your circuit. Okay. So I have A, B in, and differences A XOR with B XOR with B in, and the output is, that is borrowers A bar B plus A bar B in plus B in. Okay. So let's see, if all are 0, I have the difference 0 and borrow 0. If I have 1 0 0, as we said, if any one of the input is 1, my D would be 1, or if I want to make all input high, my D would be high, right? So, and my borrow, if I make it here, I will be having a difference 0, but my borrow would be high. It is A minus B in. So, I will be getting the difference here. If I make 0 0 1, my difference is there, and also my borrow out would be high. Okay. So similarly, if I want to look into the oscilloscope, I can very well see the change. What happens if my inputs are given. Okay, so I can see the variation in the output with respect to change in the input, right? So you can verify your truth table with this oscilloscope and the output terminals. So that's it with the simulation of full adder. And this is going to be your practice exercise. As I said earlier, design and implementation of full adder circuit, full subtractor circuit using half subtractor, and verify your results using logic gate simulator. You have the expression for the difference is the same, A XOR with B XOR with B in, but the borrow B out would be the different, right? A bar B plus A XOR B the whole bar into B in. So the hint is, as usual, you get the difference as A XOR B from the first subtractor, and the borrow would be A bar B right? A bar B, which is in the bar row. Then that is given as one of the input to the second half subtractor. Then B in would be the next input. Then here I will get the difference as A XOR with B XOR with B in. I'm fine. I'm done. Then if you see the inputs A and B, the borrow would be A bar B. And if you see here A XOR B is one of the inputs, then B in is another input. So here I will get A XOR with B, the whole bar into B in. So the second term I got. The first term of the borrow out, I get it from the borrow of first half subtractor, and the second term of borrow out, I get it from the second half subtractor, right? So finally I need to do addition. So I will make use of this OR gate to perform the addition. Finally I will get my expression B out is equal to A bar B plus A XOR B, the whole bar, into B in, right? I hope you find the useful of this video. Thank you.